Hello everyone, welcome to another video of General Mathematics of Class 9, and today we are going to do polynomials. That is exercise 2.2 of polynomials basically. So in order to understand what we have to do in exercise 2.2, we need to know what are quadratic polynomials. So quadratic polynomials mean the polynomials which has the highest order of 2. The order of the polynomial means whatever variables are going to be there in the polynomial, the highest power of the variable is actually the order. So for example, if I have a polynomial twice x square plus thrice x, here x is the variable and the highest power is 2. So this will be called a quadratic polynomial because the highest power of the variable is 2. So it is a quadratic polynomial. So quadratic polynomials can be of many types. For example, we can write this one is one of the types. It can be twice x square plus 5x plus 3 where one has no variable, or we can write only twice x square, or we can write twice x square plus 3. So these are all different types of quadratic polynomials. These are all quadratic because the highest power is 2. Okay, so now the thing is, what is the standard form of a quadratic polynomial? So a quadratic polynomial will contain constants as well as variables. So just like here we have a constant, we have a variable, constant variable. So and of different powers, highest power will be 2. So what is the uh, standard form of a quadratic polynomial? The standard form of a quadratic polynomial is ax square plus bx plus c. This is the standard form of a quadratic polynomial where a, b and c are constants. Okay, these are the constants and this is the form. Now we express polynomials as something like this: p of x equal to this. What does p of x means? It means a function of x. A function here is the expression. So an expression with the variable x. Okay, this is an expression with the variable x, which is also called the function of x. Function, f-u-n-c-t-i-o-n, function. Function of x means a polynomial or an expression in the variable x. So p of x equal to ax square plus bx plus c is the standard form of a quadratic polynomial. Now why are we studying quadratic polynomial? Because this exercise wants us to deal with the relationship between these coefficients a, b and c, means the constant coefficients, with the zeros of the polynomial. Now what does zeros of the polynomial mean? Zeros of the polynomial means for some value of x, this whole thing will have a value x square plus bx plus c. For some value of x, whatever it may be, you will get 0. So here is an equation, a quadratic equation we have formed here. So for what value of x will the value of this polynomial become 0? Those values of x will be the zeros of the polynomial. Zeros are also called the roots of the polynomial or the solutions of the polynomial. Okay, means the answer. After solving this, whatever answer you will get, those will be the roots or zeros or the solutions of x. So what we are trying to do here in this exercise is we are trying to find out what are the relations between the solutions or the zeros along with these coefficients, that is a, b and c. So let us try to see what are the relations that we have here. So first of all, the sum of the roots or the sum of the zeros. So a quadratic equation, since the highest power is 2, a quadratic equation will also have two solutions or two roots, or we can say two zeros. Okay, so any quadratic equation, for example, let us take the standard form of ax square plus bx plus c. If this is a quadratic equation, there are going to be two values of x. Okay, two values of x we are going to find. Now, how do we know what will be the sum of these two roots? So even if we don't know what are the roots, we can find the sum. How do we find it? So the sum of the roots, or we can write sum of the zeros, means the sum of the two answers of x we are going to get, is equal to minus b by a, means minus b by a. Okay, very simple. And product of the roots, means on multiplication of the two roots or product of the zeros, is going to be c by a. Okay, even if we don't know what is the zero, we can find the sum of the zeros and the product of the zeros. So this is pretty plain and simple. So now let us see what will be the, means if we know the sum and the product, can we find the polynomial? And this is possible if you only know the sum of the roots and the product of the roots. Okay, suppose a question is given where it is given that find the polynomial whose sum of the roots is 5 and product of the roots is minus 2. Using just the sum and product, you can find the polynomial. How? Here we go. So a polynomial is given by x squared, quadratic polynomial, mind it, x squared minus sum of the roots into x plus product of the roots. Okay, so this is going to be the polynomial, which is going to be, that is p of x is going to be x square minus sum of roots into x plus product of roots. Okay, I hope it is clear to you. X square minus sum of roots into x plus product of roots is going to be the polynomial in case you only know these two values. If these two values are given to you, using these two values you can find the polynomial itself. So it is like something like the answer of the question is given and you are asked to form the question. Generally what is given, the polynomial is given and you will be asked to find the solution. In these type of questions, your answer will be given and it's like we are giving you the answer. Give us the question. It is something like this. So it is the opposite of what we do. So now let us move into the exercise and see what we can solve in this exercise. So exercise 2.2, question number 1, let us see what do we have. So number 1, Roman 1, it is given x square minus 2x minus 8. So what do we have to do here? So find the zeros of the following quadratic polynomials and verify the relationships between the zeros and the coefficients. So first of all, you have to find the zero. So let us do one thing. Let this equal to px. Okay, just as we said, we are expressing it as px. Now in order to find the zeros, here p of x will become 0 because we have to find the zeros, right? Means the value of this polynomial should be 0. So px means x square minus 2x minus 8 equal to 0. So now we have to do middle term factorization as we have done in our previous classes. X square minus, we can write 4 minus 2x minus 8 equal to 0. So it is x square minus 4x minus plus 2x minus 8 equal to 0. We can take x common from here, so it will be x minus 4, and from here we can take 2 common, it will be again x minus 4 equal to 0. So we have x minus 4 into x plus 2 equals 0. This is what we get as our two factors. So either x minus 4 equal to 0, which means x will be 4, or x plus 2 will be equal to 0, which means x will be minus 2. Done. Here we have got the two zeros. So therefore, the zeros of x are 4 and minus 2. That means the two solutions of x that we have got. Second part of the sum is verification. So what we need to do is we need to check the relationship between the coefficient and the zeros. What we did here. That means you have to check that the sum of the zeros must be in the form of b by a and the product of the zeros must be of the form of c by a. So let us check this in this sum. So here we can find the sum of zeros, that means sum of these two numbers, that is 4 plus minus 2. It is 4 minus 2 which is equal to 2. Now look into this. Can you write 2 as minus of minus 2 by 1? Of course, because minus minus is plus and by 1 we can write obviously. What does this give us? What does minus 2 mean? Minus 2 here is our b and 1 is our a, right? Because the standard form is ax square plus bx plus c. So here b is minus 2, a is nothing here, means we have 1. So this is our a, this is our b and this is our c, right? So here it is of the form minus b by a. I hope you understand. So I can write of the form minus b by a because b here is minus 2, see here, and a here is 1 here. So we have expressed the sum as minus b by a. Similarly, if we check for product of roots, what we are going to get, product means 4 into minus 2. So 4 into minus 2 gives us minus 8. So we can write this as minus 8 by 1 obviously. So what does minus 8 mean? Minus 8 is our c. See, look at here, look here. Minus 8 is c and a is 1. So therefore of the form c by a, c is minus 8, a is 1 from this polynomial. So hence we have verified the sum. I hope you got it. If you have got this one, a very simple type of sum. The remaining sums you can do by yourself. Let me try one more for you. Let's do one more sum for you so that it becomes easier. Let us try question number 4. So what do we have in question number 4? Roman 4. So we have 4u square plus 8u. Okay, so let this be equal to p of x, just the usual stuff. So here we need to find the zeros, that means p of x must be equal to 0. So we have 4u square plus 8u to be equal to 0. So from here we can take 4u common and we can have u plus 2 equal to 0. So either 4u is 0 or u plus 2 equal to 0. That means u will be equal to 0 by 4, which means u is 0, or from here u will be equal to minus 2. So we have got two values of u, 0 and minus 2. Again, let's start the verification process. In verification, we need sum of the roots, or you can write roots or zeros, whatever you want, you can write, both will be correct. So it is sum of the roots means 0 and minus 2 you have to add. So it is 0 plus minus 2, which is 0 minus 2, that is minus 2. Can you write minus 2 as minus of 8 by 4? Of course, because 8 by 4 is 2 and we have the minus sign. Now what is 8 here? This is our B, this is our A. The interesting thing is we don't have a C here. So C is missing. That means C will be equal to 0. Right? C must be 0. A and B are present, C is missing. But in this we don't need C. So what we can write of the form? This is of the form what? We have this minus, 8 is our B, so it is a B, and 4 is our A, so it is B by A. Done. Now product of the roots. Product of roots is equal to 0 into minus 2. That is, it is 0. We can write 0 as 0 by 4. We can write anything. So why we write 0 by 4? Because this 4 is our A and 0 is C, because C is missing here. So C must be equal to 0. Right? So of the form C by A, C is 0, A is 4, hence verified. Very simple sum. I hope you understand this one. So now using these two examples that I have shown you, try to solve the remaining 4 sums in question number 1. Let us move on to question number 2. It is an even easier sum, because here you don't even have to solve anything. So what is given here? Find a quadratic polynomial, each of which of the given numbers as sum and products of its zeros. So number 1, two values are given, 1.4 and minus 1. What they have said, that this is the sum of the roots and this is the product of the roots. So here sum of roots is equal to 1 by 4 and product of roots is equal to minus 1. Given, this is given. As I have said, sum and products are given. Now you have to find the question. So find the quadratic polynomial. So let Px be the quadratic polynomial. Right? So now let us find out. Therefore, Px is going to be what? What is our formula? Just now we have seen in our, while we were discussing the theory, this was our formula. X square minus sum of the roots plus product of the roots. This will be the polynomial. So we will write x square minus sum of roots into x plus product of roots. Okay. So x square minus, what is the sum? It is 1 by 4 into x, and what is the product? It is minus 1. So it is x square minus x by 4 minus 1. If we take LCM, we are going to get 4x square minus x minus 4. So what we can do here, we can consider the let p of x is equal to 0. Means in order to find the zeros, we can let p of x equal to 0. So in this case, what we will get? We will get 4x square minus x minus 4 by 4 equal to 0. That means 4x square minus x minus 4 is equal to 0. Therefore, the required polynomial is, this is our polynomial, 4x square minus x minus 4. Why we did this? So that we can remove this one. So here a becomes 4, b becomes 1 minus 1, and c becomes minus 4 from the standard form. So this part you can do. This will actually give us a proper quadratic polynomial. Okay. Similarly, you can do the remaining. Let us try one more for you. Let's do one more. Suppose question number 2, Roman 2. Let us do this one. What we have here is root 2 and 1 by 3. So how do we do root 2 and 1 by 3? So here sum of the roots. So sum is given as root 2 and product is given as 1 by 3. During exam, please write sum of the roots, product of the roots. Okay, don't write it like sum and product. I am doing it for do it fast. Okay, so therefore required let the polynomial be p of x. So therefore p of x will be equal to x square minus sum of roots into x plus product of roots. This is the formula. So it is x square minus sum is root 2x and product is 1 by 3. So if we take LCM, it is going to be 3x square minus thrice root 2x plus 1. So let p of x equal to 0 in order to find the zeros. So 3x square minus 3 root 2x plus 1 by 3 equal to 0. So ultimately when you side change 3, we get 3x square minus 3 root 2x plus 1 equal to 0. So therefore required polynomial is 3x square minus 3 root 2x plus 1. This is an equation and this is an expression. So polynomial is an expression, it is not an equation. That's why we will write only this part. Okay, don't make it an equation. If they ask you to find a quadratic equation, then you will find an equation. But they have asked you to find quadratic polynomial. So only write this part. Don't write equal to 0. Only the expression is required. Done? So that's how we do question number 2. Let's move on to question number 3. Let's see how to solve that. Question number 3, what they have done, they have given the zeros. So like number 1, minus 4 and 3 by 2. So these are the two zeros. So these are the zeros of the polynomial. So in order to find the, now we have to find the quadratic polynomial. So how do we find it? In order to find the quadratic polynomial, we need to find the sum and product. So therefore sum of zeros, we need to find this first. So let's add them up. Minus 4 plus 3 by 2, that means we will get 2 minus 8 plus 3, it is minus 5 by 2. And product of zeros is equal to minus 4 into 3 by 2, so 2 will be 2, so it is minus 6. So minus 5 by 2 and minus 6 are the products, sum and the products. So therefore, or we can write let the polynomial be p of x. So therefore p of x will be x square minus sum of zeros into x plus product of zeros. So it is x square minus sum is minus 5 by 2 into x plus product is minus 6. So it is, let's take the LCM 2. So it will be 2x x square minus minus plus 5x, and this will be, since 2 is the LCM, it will be plus minus minus, it will be 12. So again we will write let p of x equal to 0. So it will be 2x square plus 5x minus 12 by 2 equal to 0. So that means 2x square plus 5x minus 12 is equal to 0 on side change of 2. So therefore required polynomial is 2x square plus 5x minus 12 equal to 0. So that's how you solve question number 3. Remaining sums are also very easy. So I hope you understood whatever we have tried to do here. We have done a few sums, so you understood what is the basic of this exercise, exercise 2.2. So if you have understood everything, try to do the remaining sums. If you have any confusion, make sure you ask me in the comment section or you can ask me directly. So thank you everyone for watching, and until next time, cheers.